Okay, so when it comes to sort of diving into vector databases, I think something that's really important to understand is the actual practical applications of why we want to use this kind of stuff, why it's important. Um, because sometimes AI can be thought of as like magic, and there's lots of buzzwords. So are we over complicating it and using vector databases because it's the cool new trend, or is it actually important to use? So that's what we're going to talk about real quick today, and we'll see why it's so important. We'll get into some actual real world examples because you probably are noticing vector databases. Well, not noticing, but there's probably vector database applications within your life every single day. You just don't notice it. So before we sort of dive into those specific examples that you see here, you've got these 10 examples that we'll go through very briefly, but essential to understand why we want to use these, why they're pivotal in the fields of AI, in the fields of machine learning. Traditional databases like Excel obviously are great at storing structured data, numbers, dates, text, where a row is sort of an identifier for the whole row of data. And then obviously, with more modern AI and machine learning models, they're going to be working with high dimensional data. On these representations are kind of the ones that are known as like our vector embeddings. So, anyways, why use vector databases? So, some key advantages. The first one is that it's for handling high dimensional data. AI models are going to output vectors, obviously, and these represent complex data relationships. So, because these relationships are complex, vector databases are designed to way more efficiently store, query, and retrieve these high dimensional vectors, unlike in traditional databases, which are going to be not as optimized for this type of task. They're going to be better for certain tasks, but not sort of like these similarity searches, as you can see, moving into our next point, because these AI applications a lot of times are relying on searching for similar items. Um, this is going to be a concept you hear repeated probably throughout this vector database deep dive, but searching through to find similar items like a similar document, a similar image, similar meanings of what we're looking for, because vector databases are able to use their algorithms in order to quickly sort of compute. We won't really get into the actual math that's taking place, computing the different points and the different dimensions between to find those relations, but that's basically what's going on. And so because of this, it's very scalable. These AI systems are often going to be dealing with massive, massive data sets. And because vector databases are built for scale, Excel has, I forget the number, but I ran into this one time at work where I hit the maximum amount of rows on Excel. And I don't know if it is like a quarter of a million or what,